Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to teach about external treatment of water and ion exchange resin. Today I am going to teach external treatment of water and ion exchange resins. Before going to this, we should know about what is softening of water. What is the softening of water? See, the process of removing or reducing the hardness of water, irrespective of whether it is temporary or permanent, is called softening of water. The process of removing hardness causing salt from the water is called softening of water. Removing of hardness means removing of hardness causing salts or ions present in the water. What is meant by softening of water? Removing the hardness causing salts like Ca+2, magnesium +2, like that. These salts is present in the water. If you remove these salts, that process is called softening of water. These salts are completely soluble in water. These magnesium and calcium hardness causing salts are completely soluble in water. So we can't remove by simple filtration. These salts can't be removed by simple filtration. See, these are the hard water. Hard water nothing but the salts which contain calcium and magnesium salts. These are softened by different techniques. Okay, we will learn those things. What are the techniques are presented to softening the water. Okay, by simple filtration we can't remove these salts from the hardness containing water. See, what is the need of softening of water? What is the purpose we have to need? What is the purpose we have to need? We have to filter or we have to convert the hard water into the soft water. See, it is very essential process since hard water is unsuitable for domestic as well as industrial use. It is very essential process, means softening is the very essential process, and hard water is unsuitable because hard water is unsuitable for both domestic as well as industrial use. We can't use the hard water for the domestic purpose and industrial purpose. So we have to do softening. Okay. One of the most important application of water is the steam production for the generation of electricity. One of the most important application of water is the steam production or electricity production of water. In the first, we have by using water, we have to produce steam generation, and then from the steam, the electricity will be produced. For this, water need to be fed to boilers. For this, the water need to be fed to boilers. Okay. Treatment of boiler feed water. Treatment of boiler feed water. The hard water using in boilers creates large number of problems like corrosion, scale, and sludge formation. The hard water, if you use for the electricity generation, okay, if you use hard water, the boiler creates a large number of problems. What are the problems? Like corrosion and scale and sludge formation. This type of formations takes place in if you take hard water in the boilers. Okay, na? For the electricity generation, if you use hard water, okay, in case of soft water, if you use hard water, these are the problems occurs like corrosion, scale, and sludge formation takes place in the boilers. The treatment of water includes the removal of hardness causing salts either by precipitation or by complex formation. The treatment of water means the softening of water includes the removal of hardness causing salts. Removal of hardness causing salts either by precipitation process or by complex formation process. We can remove the hardness causing salt present in the water by different techniques like precipitation process or complex formation process. There are two types of treatments. There are two types of treatments present in the boiler feed water. See, first one is external treatment and second one is internal treatment. There are two types of treatment are present in the boiler feed water. One is external treatment of water and second one is internal treatment of water. See, the external treatment of water. In the first one, external treatment of water. The treatment given to water for the removal of hardness causing salts before it is taken to the boiler is called external treatment of water. What is external treatment of water? The treatment given to water for the removal of hardness causing salts before it is taken into the boiler is called external treatment of water. Okay. Before water taking into the boiler, if you treat that water, that process is called external treatment. Okay. Before the water taking into the boilers, okay, we have to soften the water. Okay, that process is called external treatment of the water. The treatment given to the water for the removal of hardness causing salts before it is taken into the boilers is called external treatment of water. This treatment prevents the boiler problems. This treatment prevents the boiler problems because before say water sending into the boilers, we have to treat that water. So this treatment prevents the boiler problems. It can be done by means external treatment can done by lime soda, zeolite and ion exchange process. The external treatment can be done by using lime soda process, zeolite process and ion exchange process. What is internal treatment? External treatment nothing but the treatment given to the water for the removal of hardness causing salts before it taken into the boilers. Okay, na? What about internal treatment? Internal treatment nothing but internal treatment for boilers feed water refers to the conditioning of water in the boiler itself by the addition of chemicals. Okay, in external treatment, before water taking into the boilers, we have to treat that. That process is called external treatment. But internal treatment, okay, internal treatment nothing but after water taking into the boilers by addition of chemicals, we can remove the or we have to treat the water. That treatment is called internal treatment. Inside the boilers, if you treat the water, that process is called internal treatment. This is essentially corrective method to remove those salts which are not completely removed by external treatment of water softening. Okay, if external treatment if external treatment nothing but the treatment of water before taking into the boilers. Okay, if after external treatment, if any salts present in the water, okay, that water sending into the boilers. Okay, inside the boilers, if you treat the water, if any salts present in the water after the external treatment, we can remove by internal treatment method by adding some chemical substances. Okay, the conditioning methods used in internal treatment are colloidal phosphate, colgan and carbonate conditioning. The conditioning methods, these are the conditioning methods. What are the internal treatment conditioning methods? Are colloidal and phosphate, colgan and carbonate conditioning methods. These methods will be used for the internal treatment of the water. See, ion exchange process and demineralization and deionization process. Both these three are same. Okay, ion exchange process nothing but demineralization process nothing but deionization process. These are the example for the external treatment of the water. These are comes under external treatment of the water. Means before taking the water into the boilers, okay na, we have to treat the water. That process called external treatment. Okay na, these are the example for the external treatment. What is that? Ion exchange process or demineralization process or deionization process. See, in this method, ion exchange resins are used as softening materials. In this method, we have to use ion exchange resins for the softening of the water. Okay. In this process, cations nothing but calcium, magnesium, and anions nothing but chloride and sulfate ions are removed by cation exchange resins and anion exchange resins. By using cation exchange resins, we can separate the cations. By using anion exchange resins, we can separate the anions present in the water. Okay. At the end of the process, outcomes water does not possess any type of ions, means deionized water. At the end of the process, outcome water, resultant filtered water does not possess any type of ions. It does not contain any type of ions, means we get deionized water. By using ion exchange resins, we can get the deionized water, means the water which did not contain any ions. Okay na, that's called deionized water. Ion exchange resins. What are the ion exchange resins? Ion exchange resins. See, ion exchange resins are insoluble. The ion exchange resins are insoluble in water, and these are cross-linked. These are the example for the cross-linked polymers and long-chain organic polymers. The ion exchange resins are long-chained organic polymers with a microporous structures. These polymers contain some type of micropores present on the surface of the resins. Okay na? These are the characteristics for the ion exchange resins. What are the ion exchange resins? Ion exchange resins are insoluble and cross-linked and long-chain organic polymers with a microporous structures. The functional groups attached to the chains are responsible for the ion exchanging properties. The functional groups which are present on the surface of the resins, okay na, those are reason for the ion exchanging properties. Okay na, the functional groups which are present on the surface of the polymers, those are responsible for the ion exchanging properties. See, The ion exchange resins are classified into two types. The ion exchange resins are classified into two types. What are they? Means see, cation exchange resins and anion exchange resins. The ion exchange resins are classified into two types. First one is cation exchange resin and second one is anion exchange resin. The cation exchange resin is denoted by R minus and H plus. The cation exchange resin is denoted by R minus and H plus. As well as anion exchange resin is denoted by R plus and OH minus ions. Okay, the anion exchange resin is denoted by R plus and OH minus ions. See, cation exchange resins, nothing but R minus H plus. We can denote it by R minus H plus, nothing but cation exchange resin. Cation exchanges are capable of exchanging their H plus ions with cations of dissolved salts. If the water contain, okay, if water containing any positively charged ions, means cations present in water, those are replaced by the H plus ions present on these cation exchange resins. The H plus ions are capable of exchanging the ions present in the cations present in the water. Okay, the cation exchange cation exchanger are capable of exchanging their H plus ions with cations dissolved in the salt. These H plus ions are capable of replace the cations present in the water. Okay, which comes in their contact when the positive ions are comes in contact with this resin. The cation exchanges are represented by general formula RH, are mainly styrene divinyl benzene copolymers containing the functional groups COOH and SO3H. Means the cation exchange resin contains, these are the functional groups. What are the functional groups? One is carboxylic acid and second one is sulfonic acids. The cation exchange resin contain, these are the functional groups. C double bond O is nothing but carboxylic acid functional groups or sulfonic acid functional group. The carboxylic acid means C double bond OH, means here O minus H plus ions can form. So these H plus ion can capable of replace the positive ions or cations present in the water. Okay. Similarly, sulfonic acid. Sulfonic acid nothing but H double bond O minus H plus. These H plus ions reason for the exchanging the capable property of this functional group. Okay. R is the general structure of resin and H is exchangeable with cation. Here the H plus ions are exchanged with cations. Examples: sulfonated coals and sulfonated polystyrene. These are the example for the cation exchange resins. See, this is the structure for cationic exchange resin. This is the polymer. Okay, this is the polymer. This is SO3 minus H plus and SO3 minus H plus. These are the functional groups present on the cation exchange resin. Okay, this is the example for cation exchange resin. This cation exchange resin contain the functional group sulfonic acid. Here the H plus ion is capable of exchange the positive ions present in the water. Okay. See, anion exchange resin or R plus OH minus, we can represent it with R plus and OH minus ion. Anion exchange resin. Cation exchanges are capable of exchanging their OH minus ions with cations of the dissolved salts. Sorry, anions of the dissolved salts. Cation exchanges are anion exchanges are capable of exchanging their OH minus ions with anions of the dissolved salts, which comes in their contact. Here the OH minus ions present on the surface of the polymer. Okay, polymer or resin. Okay, these are the reason for the exchanging. Okay, exchanging the negative ions or anions present in the water. Means the OH minus ions replace the anions present in the water. Okay, when they which comes in their contact. Okay, na? If the water contact with these anion exchange resins, means the OH minus ions present in these anion exchange resins replaced by the anions present in the water. Okay. The cation exchanges are represented by general formula R plus OH minus. The anion exchanges are the anion exchange resins are represented by R plus OH minus. These are the functional groups present on the anion exchange resins. What are those functional groups? See, the ROH means alcoholic functional group means, and RS and RNH2. These are the functional groups are present on the anion exchange resins. Cross-linked quaternary ammonium salts and urea formaldehyde resins. These are the example for the anion exchange resins. See, this is the anion exchange resin. Here NME2 OH minus means quaternary ammonium salts. These are the functional group present on the polymer or resin is called ion exchange resins. In this, the functional group is quaternary ammonium salt. Here the OH minus ions. Okay, this OH minus is reason for the exchange of anions present in the water. Okay, see here the water, the cationic resin, here the anionic resin. Okay, here we are taking cationic resin, here we are taking anionic resin. We are sending water with the water contain calcium chloride, means one Ca plus 2 positive ion or cation and Cl minus anion. First we have to send this, the calcium chloride contain water. This calcium chloride water containing water we have to send into the cation exchange resin. Okay, here the cation exchange resin contain H plus ions. Okay, the cation exchange resin contain H plus ions. These H plus ions are replaced the Ca plus 2 ions present in the water. Okay, the Ca plus 2 ions are replaced by these H plus ions. Okay, then the only it is sent after filtering. Okay, now after the outcome is the water does not contain any cations, means the water contain only Cl minus ions. Okay, now after then we have to send into the anionic resin. The anionic resin nothing but it contains OH minus ions. Okay, now these OH minus ions replace the Cl minus ions present in the water. In cation exchange resin, the cations are separated. In anion exchange resin, the anions present in the water are separated. The resultant, the H plus and OH minus ions comes out from this water. Okay, the Ca plus 2 attached to this cation exchange resin and the Cl minus, the anions present in the water are attached to the anion exchange resin. Here the H plus ions and OH minus ions are comes out. Those will form water. Okay, this is the process present in the ion exchange resin. See here, this is the cation exchange resin, here anion exchange resin. Okay, first if you send raw water into the cation exchange resins, if raw water contain any cations, okay, positively charged ions, those are separated in the cation exchange resins. Okay, the resultant water only it contains negative ions. Okay, now the cations are separated by here cation exchange resins, or cations present in the water are attached to the cation exchanger. The outcome water contains only negatively charged ions. Okay, these negatively charged ions of containing water then send into the anionic exchange resin. These anion exchange resins, these are OH minus ions are replaced with the negative anions are present in the water. So here all the negative ions present in the water are separated in anion exchange resin. Okay, all negative ions, negative charged ions are attracted by the anion exchange resins. Only here OH minus ions comes out, here H plus ions are comes out. These together form water. Okay, then outcome the water which does not contain any positively charged and negatively charged ions. Only the pure form of water will comes out. Okay, this is the process of ion exchange resin process or reionization process. See, these are the reactions involved in the ion exchange process. In cation exchange resin, the cation exchange resin nothing but that formula is R minus H plus. Here H plus ions are replaceable. Okay, when these water contain calcium and magnesium salts, means the water contain any hardness, means calcium and magnesium salts. The water contain calcium and magnesium positive charges, means cations. If water contain any type of cations, those are reacts with these cationic exchange resins. Okay, these reacts with cation exchange resins. Here the H plus ions replaced with Ca plus 2 ions, means Ca plus 2 ions reacts with 2 R minus ions, forms R2Ca. It forms R2Ca and it releases 2 H plus ions. Similarly, the magnesium plus ions present in the water, those are reacts with the cation exchange resin. It forms R2Mg and releases 2 H plus ions. Okay, these are the chemical reactions involved in the cationic exchange resin. In anionic exchange resin, in case of anionic exchange resins, the structure of anionic exchange resin is 2R plus and OH minus, 2R plus and OH minus ions. Okay, now if water contain any negative ions like chloride and sulfate ions, okay, now those are reacts with these anion exchange resins. Okay, the OH minus ions are replaced with Cl minus, forms 2 Cl minus reacts with this anion exchange resin, forms RCl and releases 2 OH minus ions. the Cl minus reacts with anion exchange reagents, it forms RCl and produces 2OH minus ions. Similarly, the sulfate ions present in the water reacts with 2ROH, means anion exchange reagent, forms sulfates, okay, na, R2SO4, and it releases 2OH minus ions. These are the chemical reactions involved in the anion exchange reagent. See, after several days, if you use the anionic and cation exchange reagents for several times or several days, okay, what happens? All the positively charged ions are attached to the cation exchange reagents, and the all negative ions are attached to the anion exchange reagents. There is no possibility for the replacing H plus ions after several days. So all the resins are exhausted. Okay, after several days, after several days, the resins will be exhausted. So we have to regenerate those resins. See how we can regenerate those. Regeneration of exhausted resins. Okay, after several days, after several times of uses of resins, the resins will be exhausted. So we have to regeneration of exhausted resins. See what is the process involved. The saturated cation exchanger is gotten back by passing dilute HCl. The saturated cation exchanger is gotten back by passing dilute HCl solution. Okay, see R2Ca means the resin is saturated with positively charged ions. If you send dilute HCl, means dilute sulfuric acid, again it will form 2RH and CaCl2. Again 2R is nothing but this is the cation exchange resin. Again it will form cation exchange resin. After saturation of saturated of cation exchange resin, if you send dilute HCl to the cation exchange saturated, then it produces the cation exchange resin with its formation of calcium chloride. Similarly, if the cation exchange resin is saturated with magnesium salts, if you send dilute HCl to that saturated cation exchanger, that will form the cation exchange resin. Pure first instead the pure form of cation exchange resin will form, and it result magnesium chloride. The calcium chloride and magnesium chloride removed by washing. These are the precipitate. Okay, now we can remove by using simple by washing. Okay. The saturated anionic exchanger is gotten back by passing dilute NaOH solution. The saturated anionic exchanger is gotten back by passing dilute NaOH solution. See, RCl means all the chloride ions are attached to the negatively or anion exchange resin. So these are saturated type of anion exchange resin. Okay, the regeneration of exhausted resin by using dilute NaOH. If you send NaOH to this saturated anionic exchange resin, it forms ROH. ROH nothing but R plus OH minus. Other name of the anionic exchange resin. Means the anion exchange resin is regenerated. The anion exchange resin is regenerated by using passing NaOH to the saturated anionic exchanger. Okay, that results NaCl. Sodium chloride will be resultant product. And similarly, the negatively charged anionic exchanger means sulfate. These are here the sulfate ions are saturated with this anion exchanger resin. So these the anion exchange resin in this case regenerated by using sending NaOH. If you send NaOH to this anionic exchange resin, it forms ROH. ROH means this is the anion exchange resin regenerated form, and it produces the Na2SO4 salt. The product will be the sodium sulfate salt. The NaCl and Na2SO4 means sodium chloride and sodium sulfate are removed by washing, and the regenerated ion exchanger can be used again. Okay, now after regeneration, again we can use these cation and anionic exchange reagents for the ion exchanging process. Thus, the water coming out from the anion and cation exchanges is free from both cations and anions. The water coming out from the anion and cation exchanges is free from both cations and anions. The outcome water, it does not contain any cations and anions. This water is known as ion-free water or deionized water or demineralized water. This water is known as ion-free water, and also we can as deionized water, and we can also call as demineralized water. Advantage. What are these advantages present in the deionized water? See, it produces water hardness is very low, means it 2 ppm. Okay, na? The hardness water after if you the outcome water content, the hardness of water is 2 ppm, less than 2 ppm, means it produces very low hardness. Okay, the outcome water content very low hardness. Okay, this process can remove both anions and cations. By using this ion exchange resin process, we can remove the both anions and cations present in the water. It can be also used to soften high acid or basic hard water. By using this ion exchange resin process, we can soften the water if water contain high acid and basic nature containing. Okay, na? It can also remove the cations and anions present in the water, and also we can soften the water which contain high acidic nature and high basic nature containing water. What are the disadvantages present in this ion exchange resin process? See, equipment chemical resins are more expensive. The chemicals which are used in this ion exchange process is the resins which are used for this ion exchange resin process are more expensive. The resins are more expensive. So this process is related to the more expensive process. These are the advantages present in the ion exchange resin process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.